let's just see where we're at on some of these things. Make sure if you have your phone out, go put it away, please. And I need to know where you guys want me to start. I'm kind of a mismatch right now since this Friday we're in a lab. So they were good. Ours had an artificial shoulder, so we were able to see an artificial shoulder. It's pretty cool. Awesome. 5-3? Works for me. So using the Z table backwards, right? Okay. All right, starting at 5.3, using the Z table backwards. Hold it down, please. If your neighbor's talking, tell them to hush. Then I'll be quiet after that, poke them in the eye. Okay, so I am on 5.3, using the Z table, working backwards. Let's make sure we're going to do this. Answer the following. Don't forget to do a quick sketch, the picture for each. Towns average snowfall is 48 inches per year. Standard deviation of 6. Use normal model for drawing the pictures. For each problem, find the percentage of years where the snowfall is at least. All of those. Okay. So this is problem number 1. Let's kind of just draw a normal curve. So we know that this is 48. And so we have a standard deviation of 6. Okay, so that's basically what our presentation is right now. So at least 62. Okay, so 62 or more or 62 or less. What does at least mean? 62 or less. So where does 62 fall? Does it fall right on one of our standard deviations? Describe to me where you think it would kind of fall for right now. To the right? How many standard deviations to the right do you think?
2.
About a little bit more than 2. It's falling in right there. You agree with that? So let's figure out at least 62. So I think we can find a z-score of that. So we have our observed minus our average over our standard deviation. If you have a calculator out, will you do that for me? 62 minus 48 comes to 2.33? Why are you going 1 minus that? Okay, so we're going to do 1 minus it. What do you got? Someone told me 2.33? Okay. So the z-score is a way of looking at it as a standard deviation. So we are 2.33 standard deviations above the average. Follow me, please. Follow me, please. Wow. Maybe.
Yeah, there's a colored pencil.
It's white though. Pencil, yeah. Yep. All right, so 2.33 means 2.33 means we are 2.33 standard deviations above the average. I'm going to go figure out the area for right now. So I'm going to table A. I'm looking up 2.33 in the table. 2.33 looks like 0.9901. So right now you're at the 99th percentile, if you wanted to do that. And so we want at least 62 inches. At least 62 inches. So someone said we need to go 1 minus because it's at least. What do you think? Yeah, so I want at least 62. It could be more than that, but I want at least 62. What's the chance we're going to get at least 62 inches or more snow this year? So I'm going to take this value, our percentile, and I'm going to go 1 minus that. And what does that give me? What is it? .0.099. Or is that? There's two zeros. .0099. Okay. So that means that we have a 0.99% chance of getting 62 or more inches of snow in that given year. Okay, letter B says at most 45 inches. At most 45. So at most 45. What does that mean? Am I going 1 minus it, the area at the end or not? Okay, at most 45. At most 45, we graphically are somewhere in there. So we are to the left of the average, but we're not 1 standard deviation below the average. So we're still falling amongst the 68% of the population. So at most 45. So I'm going to figure out my z-score here. Z equals 45 minus 48, which is the average, over the standard deviation, which is 6. So that's going to give me 3 over 6 equals half, which is 0.5. Did I do that right? Ooh, and it's negative. The negative means we're to the left of the standard deviation, or of the average, excuse me. So negative, go to your z-scores for negative by negative 0.5. 0.5 is 0.3085. So that means that we are in the 30th percentile for the most part. What's the probability that we will get at most 45 inches? 30.85%. Okay. And then letter C, between 50 and 60 inches. Between 50 and 60 inches. I'm going to just erase this. Okay, so between 50 and 60 inches, what we have is this. We're talking about an area of this. Okay. So I can find the z-score in the area at 50 and find the z-score, God bless you, in the area at 60, or I can bust out the calculator. Bust out the calculator. So if we use the calculator, what is it called? What's the one called? Remember this? This is the lower, the upper, the average, and the standard deviation. Remember that? So what would my lower be on the calculator on this particular problem? What's my lower limit on this one? 50. What's my upper? What's my average? 48. What's my standard deviation? 6. So let's use the calculator to find it. So again, I could have found the z-score, found the percent of each. That corner behind Lenny is talking too much. I'm sure it's not Lenny at all, though. All right, so I'm going to find the normal CDF. And we're going to do 50 and 60. What was my average? 60, 48. And standard deviation was? 6. Thanks. So if we use this correctly, our area between 50 and 60, our probability we get between 50 and 60 inches, excuse me, is 34.7% roughly. guys want to continue your conversation, just stand in the hall, please. All right. Does that make sense? So that's the area. That's the area underneath the curve. We take a look at this. This area right here, that shaded area right there, is. I guess it's coming. Woo! Thank you. Woo! Does that make sense? So normal CDF, upper and lower limit. A lot of times, if we went back to, say, problem number 1, we could have done this the same way, where I could have done the lower versus the upper. So if I did the 1 minus, that's fine, but 1 minus, that would have meant my lower bound would have been the 62, and my upper bound would have been like 10,000. Okay? But it would work for us. On letter D, more than 70 inches. So more than 70 inches. Okay? Let's do this on the calculator using normal CDF. So second entry. So we want more than 60 inches. So my lower limit is going to be 60 inches. Or 70, thank you. Thank you. Normal CDF, my lower is going to be 70. My upper, do we know what our upper is going to be? So pick a bigger value than 70, something that's way more than a few standard deviations away. So we can pick like 500. Okay? Okay, some people might say pick 1,000, whatever. And then what was my 48 was my standard deviation, and my 6 was my average was 48, and so what does this number mean? Yeah, 0.00012. What I could do with this, if I wanted to figure out the area, multiply by 100. So that's the percent chance, 1.2, that we will get more than 70 inches of snow in that particular environment. Letter E, between 60 and 80, normal CDF, 60, 80, 48, 6, enter. What's that? It's under second bars. So second bars, number 2 and number 3. The 2 and 3 are the two numbers we use. Number 2 is going to find us the area under the curve. Number 3 is if we already know the area under the curve and we wanted to find what the score was, that would relate to it.
Sorry if it takes us to like different page and doesn't put it in the calculator thing. Yeah, well, they have a newer OS.
So it'll
Same thing.
it's the same thing. Yeah, yours allows you to put it down through a column, right?
Yeah.
And then you hit calculate. And actually, I think when you hit calculate, this will show up to look like my screen.
Okay, cool.
I think it'll show up like this afterwards once you hit enter. All right. So F less than 35 inches. So you go 0, 35, 48, 6 on the normal. And then after that we go G, H, and I. Okay, G, H, and I. So let's work G and H first. Let's make sure we can make G and H work for us. We have highest 10%, which is the same thing as 0.1000, which means this. Highest, we're talking about, this is the area that we know. Okay? So we can do one of two things. We can work backwards from this, where I could look to see what z-score would give us 0.1000, And if you went back to your table in the back of the book, which is totally fine to do, you're going to try and figure out as close to 0.1 as possible. It's going to be on the negative z-score page. So 0.1 looks like about negative 1.28, which means that's your z-score. Then if you used your z-score, so if you used your z-score and worked backwards, you could get this. We're still looking for the observed. Minus x bar, 48 was the average, I think. Standard deviation was 6. So if you went and used algebra and worked that out, you'd be able to find your observed score pretty easily. Someone with a calculator, negative 1.28 times 6. Add 48 to that answer. 40.32. So it appears that we would have 40.32 inches of snow. Did I do that right? Our highest 10%? Or are we off? I think I made a mistake there somewhere. Yeah. So let's double check this. Let's use the calculator. Alright, let's see if we can make that work. So if I go second, inverse normal. I'm going to plug in 0.1, comma, our average is 48. Our standard deviation is 6. Oh, you know what I did? I'm going to show you what I did. Hang on, I'm going to do this just to verify I get the same score. Yeah, so we totally got that. But what happened? What did I do wrong? Is this right here 10% of the information? This shaded area here. So what does the normal curve normally have? What part? It usually has this area. So what is this related to? What area would it be? Yeah, we're going to do 1 minus the, I'll have it there. We're going to do 1 minus our, whatever our calculator runs. 1 minus the 0.1, so we're talking about 90%. So this is correct if we wanted the area down here. I wanted the area up on top, so I had to go 1 minus that. So just change it up on my calculator. Second entry, inverse norm. I'm going to change just one number. I'll make that a 0.9. So this would be if you had 55.7 inches of snow, then you would have been in the 90th percentile or above. Okay, the lowest 5%, how many inches? So what's the difference between the lowest 5%? What is that? What area is that? The area over here or the area over here? Left or right? Left. So right here we're looking at 5% of the area. So that's 0.05. And if I do that inverse norm on the calculator with that 0.05, so second entry, inverse norm, I'm going to change this to point what? 0.05, isn't it? And you have to do an insert because we have to second insert 0, change the 9 to a 5. Hit enter. Oh, so I got 99. So 38.1 inches of snow or less is your lower 5% of your thing. And then the middle 50% of the years had how much snow? The middle 50% of the years. What is that saying? What do you think? Middle 50%. What does the middle 50% account for? The mean? I think we're talking about that. Middle 50% does not necessarily mean this is a standard deviation and this is a standard deviation. Middle 50% means you have Q1 and Q3 subtracted. You're talking about half your data. Okay? I'm going to actually hold off on this question because I know I'm not going to ask it on the test. Okay, number 2 is going to be done the exact same way. And then the next page, 5.4, which was done on the Friday, that should, let's see, calculated. So worksheet 5.4 had a few things that are new to us. Say, a lot of times they might have it listed like this. This means it's a normal distribution. This is your average. This is your standard deviation. Okay, that's just how they have it listed. Okay? So problem number 1 there, I'm just going to go through quick, is going to be the normal CDF. 70, 90, 75, 8. Because they're going to ask you if the test scores are class are distributed, with that, what percent will fall between the 70 and the 90? Okay, so again, you're looking at a normal curve, talking about an area in between two particular values that you're looking for. Number 2, if test scores are distributed 70 to 8 or 75 to 8, approximately what scores you need to be in the top 5%. So that's the second problem is going to be one of the inverse norm scores. And if you use the top 5%, you're talking about 95% of the area under the curve. That's your average. Standard deviation, you plug that into the calculator and you get it. And then number 3 says, hey, if you were going to have that big cholesterol and you had this, 180. I'm going to use my normal CDF. So if I wanted what percent is higher than 210, I'm going to go 210. I'm going to put in a large number. So make this significantly larger, 1,000. 500 might not be enough. It might be because you have standard deviation 20. But this has to be a much larger number than this. Make sure it's well outside of your couple standard deviations away. And then you're going to have 180, 20, and that's going to give you the area in that scenario. And then number 4, IQs are normally distributed. The mean of 100, standard deviation of 15. Approximately 90% of the population has IQs between what numbers? So if you wanted to know what 90% of your population fell in between, you're doing this. So you can do inverse norm of 0.05, 100, 15, because they said that it was, mean was 100, standard deviation is 15. And then you're also going to do inverse norm. 0.95, comma 100, comma 15. This is how you would have done that 50% problem as well. But this one works a little nicer for us. Okay, is there any other questions off of that 5.4 worksheet? Yay, nay, may? We good? May I move on? Anyone need a stretch? Anyone need a pause for a minute? Okay. In 3, 2, 1. Here we go. What happens when you have two normal distributions you want to compare them? So you figured out boys' scores and girls' scores. You wanted to compare them. So if you know you have two normal distributions, and this is going along in 5.6, this is the last portion of this unit. So let's say we had scores x and y. And then we wanted to combine them. So if I have two normal distributions and I add them together, then the added together normal distribution will be a normal distribution as well. Okay? If I subtract them, same thing. So literally, you have this kind of scenario. And then if you wanted to know the standard deviation here, this is going to, or the average here, this is going to give me 7. And if I add the two together, that gives me a standard deviation of 12. If I have my average is this, or my mean is this, and then if I wanted my standard deviation, or I found my standard deviation found it to be 3.266, let's say I went through it the longer way, or I can plug it in the calculator, and then this standard deviation is 4.082, then I have a standard deviation of this. So when I have that, then I can go about and combine information. Okay? So we're going to go through this, and if you flip over to the next page is going to do the same thing, but you're going to do x minus y. So 1 minus 2 would be negative, 5 minus negative, 9 minus 12 would be negative 3, so on and so forth. If you found your average, when subtracting, it would be a negative 2, but your standard deviation, though if you were to subtract them, if you want this minus this, rather than this plus this, it should come out to a negative answer, but you want this to always be positive. So let's just see, how did I get the values? So I want this plus this to get this, that makes sense. I want this minus this to get this. I want this plus this to get this, and I want this minus this to get a positive version of it. So my standard deviation has to stay positive. Okay. So if I had, let's say this is boys, girls, and let's say we just had a list we knew was normally distributed, and we wanted to start comparing the combination of the two. So I can either add our stuff together or subtract it. So this is just given data as far as our list goes. And this is just given data. So how I'd get this is I'd go 1 plus 2 is 3. So this would be like if I were to say, if I wanted to know what your average and his average would be together, I would add. If I wanted to say I want to know the difference between your average and his average, I would subtract. That's all I'm doing. So when you go through and you take a look at this is just filling out the chart. I think if I go through the example below, it's going to make a little bit more sense. It's kind of hard to read this because you're like, where is this information come from? The 159, 2, 7, 12 is made up fictitious data. We found the average by adding them up, divided by 3, add them up, divide by 3. Found the standard deviation. Basically, I could have done it the long way by standard deviation or plugged it into my one variable statistics on my calculator. Either way, you're going to get the right answer. But I'm going to go through the example, see if we can figure this out. It is known that the heights of males are normally distributed with a mean of 69 inches. So males, we have a mean of 69. We have a standard deviation of 2.5. And then the female population, we have an average of 63.5 and a standard deviation of 3. Okay? So that's just our given information. So and then letter F down here says, if we pick one male and one female, find the probability that the male is taller than the female. We want to know the probability that the male has a greater height than the female. Does that make sense so far? Now I'm going to do a little leap of faith here, a little bit of algebra. If I have M is greater than F, can that tell me that M minus F is greater than 0? If the boy is bigger than the girl, so I take the boy's height and the girl's height. The boy's height is bigger than the girl's height. If I go boy's height minus the girl's height, will it still be greater than 0? Does that make sense okay? So that means I would like to find the probability of, that's where my leap of faith is. Is that okay so far? Okay. So I have the information up here to do it. So if I wanted to find this, I'm going to subtract them. Why am I going to subtract them? Because of this. So I'm going to go 69 minus 63.5. So my new average is 5.5. Let me stop. So everyone see where my numbers came from. Took the average of the guy minus the average of the girl. Why did I do that? Well, I want the probability that the male is greater than the female as far as height goes. So then using a little bit of algebra, I have to realize that M minus F is greater than 0. That M minus F is what goes back to here. Okay? And then my standard deviation is always what value? Positive or negative? It's always going to be positive. So then my standard deviation, I'm going to go 2.5 minus 3. That's going to give me negative 0.5, but my standard deviation has to always be positive. Is that okay? Now all we're going to do is just use our z-table. Okay? Remember, my z-score is this. Observed minus our average over our standard deviation. That's my observed. 0 minus my average, my new average, over my standard deviation. What is negative 5.5 divided by 0.5? What do we get? Or negative 1.1, sorry. 1.1. That's my z-score. That means I am below. What did I do? Did you go negative 5.5? You got negative 11? Negative 11? Oh, wait. Hang on. Not match my answer. Sorry, hang on a sec. Uh-oh, what did I do wrong? I know I did something wrong. I goofed it up. Ah! Ow. Forgive me a moment. I goofed. I goofed real quick. Oh, I'm so sorry. Right here. I goofed. So, x minus or x plus. Okay, that was for my standard deviation. Sorry, it's written there. I totally goofed on that. I am so sorry. So hang on, I got to goof this up. This is going to be changed. I goof that. Just erase it. I'm sorry. Didn't mean to goof that up. That needs to be erased now. And that needs to be erased there. I need to find my standard deviation. Woo! Man, let me tell you. All right. So I'm subtracting these. So the standard deviation, I'm going to get square root of 2.5 squared plus 3 squared. 6.25 plus 9, which is 15.25. Square root of 15.25 is 3 point what? Square root of 15.25 is square root of 3 point what? Square root of it. 3.905. That's going to be a different answer. All right. Sorry about that. I'll go back and recap this a second. All right, so what is negative 5.5 divided by negative 5.5 divided by 3.905? Negative 1.40. Table in the back of the book. You're going to look up negative 1.40. Okay. So males greater than females. So male minus female. So right now what we had found is 0.808 or 0.0808. So you're talking about 8% of the population would have that female be taller. So you're talking about roughly 92% of the population has the male being taller. And I chased this dog far enough around a tree to goof a couple of you up. So what I'm going to do is this. This is what I have planned between, let's see, today's Monday, right? No? Jeez, I'm losing days already. So tomorrow what I want to do is we're going to go briefly through the worksheet that would go along with this. Don't worry, you don't have to do it tonight. We'll make it better tomorrow. Also tomorrow we'll do the group portion of the quiz. The following day is a small, like 5-problem individual portion of the quiz, as well as review. What day am I on now? Tuesday, Wednesday, Thursday. So Wednesday will also be review for the test. Thursday will be the test. Friday will be Orange Story, or if you need to finish the test. Giddy up.
He's here today.